With an understanding of the operations that TCP performs, it is appropriate to understand now how TCP implements flow control and the measure of sequence numbers that it adopts. How effective is that? In this module, we shall see how TCP implements flow control, how is the receiver going to advertise a reduced window back to the sender to throttle the data rate, what is its effect on the sender window, and the overall effective window that is based on the effects of the receiver window and the sender window. So when a receiver realizes that the sender is transmitting at a faster rate than it can handle, the receiver throttles the sender by advertising a window that is the range of sequence numbers that it can accept. This range of sequence numbers has to be smaller than the range of data it can buffer locally. This is implemented by TCP on the receiver side, which takes into consideration this relationship that the maximum receive buffer has to be at least equal to or greater than the difference of the last byte received and the last byte read. The relationship between the received and read bytes is that if the data is being received at a very large rate, but it is being read slowly, it is going to result into reduced buffer availability. But if the data is being received at a large rate and at the same time it is being read very quickly also, so that will keep the buffer available and sender can transmit at unthrottled rate to the receiver. If there is a local process at the receiver and it reads data as fast as the data arrives, so what will happen? The counter of the last byte read shall be incremented at the same rate as the last byte received. Consequently, the buffer would virtually stay fully available, and the advertised window would be the complete range, that is, it is the maximum received buffer. But on the contrary, if the receiving process is slow, the advertised window steadily gets smaller till the time that the window is reduced to 0. In TCP implementations, it is an unwanted situation because it is going to lead to advertisement of zero-sized window, causing silly window syndrome. There are mechanisms to adjust for this discrepancy as well. If we look at the relationship between the overall receive buffer and the receive window it can advertise, let's look at the overall memory which is available at the receiver. The incoming data at the transport layer occupies the part of memory on the right hand side, and the spare room shown in blue is steadily reduced. When the application process starts munching data at a faster rate, this memory occupancy shall be relieved rather quickly. So the advertised window is going to be such, it is going to be the difference of the maximum receive buffer, that is the total buffer size, minus the sequence number of the next byte expected minus 1, because in TCP implementation, the next byte expected is always plus 1, the expected sequence number, and the last byte read. This relationship shall determine how much buffer availability can be advertised to the sender. When the sender receives this, it has to abide by the upper bound given by the advertised window of the receiver, such that the last byte that it has sent and the last byte that was acknowledged would have a relationship with each other. That is, so if whatever has been sent, if it has readily been acknowledged, so it means it can transmit at an unthrottled rate. But if what has been sent has still not been acknowledged, and this gap between the sent and acknowledged sequence numbers increases, it would eventually be limited by the advertised window from the receiver side. The effective window shall be based on the overall relationship between what has been advertised and what is being offered and the sender side by this relationship. So when we look at the receiver side, we are concerned with the occupancy of the max receive buffer, and on the sender side, maximum send buffer. The relationship between these two is that the maximum send buffer is now related to the last byte which has been written by the user application and the last byte which has been acknowledged. So we can easily understand if everything that has been written by the application layer has already been acknowledged, it means that the receiver is in fairly good condition and is willing to receive more, and it affects the send buffer indirectly.